Welcome to our guide to building a Tone Bender MKII effects pedal. In this video we'll be building the Germanium transistor kit supplied by Fuzz. The video is divided up into convenient sections. Whilst it isn't a step-by-step guide, we really get into the weeds in some sections, so you can skip ahead and see the sections that matter to you if you want. There are links to each section in the description below. In this video we cover why build a pedal kit, an introduction to the Fuzz Tone Bender Pro MKII kit, history of the Tone Bender, Germanium transistors, what's the deal, tool list, assembly sequence, testing, final assembly, sound test and conclusions. So why build a pedal kit? Over the years I have designed and built electric guitars from scratch, and I have also designed and built tube amps. As an extension of that, I have also built a number of effects pedals, including 5 Fuzz kits: Tube Screamer, Fuzz Face, Super Squisher, Range Master and a circuit tester. With the exception of one pedal, they all work first time, and the issue with that pedal was easily fixed. I have never needed troubleshooting support from a kit supplier, so I must have been doing something right. I've always enjoyed building them and using them. And so in late 2020, to ward off the effects of lockdown, I decided to build another Fuzz kit, a Tone Bender MKII. I found that building an effects pedal from a kit is a fun and rewarding pastime. It's also a way of getting great sounds on a budget. There were challenges along the way, but I really enjoyed sorting them out. In this video we'll be building a modern version of the Tone Bender MKII using a PNP Germanium kit. It was timely to build this kit since, coincidentally, Boss have just announced a deal with the original manufacturer Solar Sound to make the Boss TB2W Tone Bender, which is their take on the MKII. The original Tone Bender MKII used in the main OC75 Germanium PNP transistors, which are now rare and generally only available in expensive boutique pedals. You can order the Fuzz kit with European transistors, which are either AC125s or AC128s depending on availability, which is what I did, or a version with American 2N404 transistors. You can build the original Tone Bender MKII, or, with a couple of small circuit changes, a Marshall Super Fuzz or a Vox Tone Bender MKII. I chose to go with the original Tone Bender. So, how does the circuit work? Firstly, you have to know that transistors amplify current, while valves or tubes amplify voltage. However, the amplification principles used are the same. A simplified representation of the signal path is shown by the red line going through the middle of the schematic. In the schematic, capacitor C2 allows only the audio signal, which is an alternating signal, through to the base of transistor 1 marked Q1. Current can flow from the emitter of Q1 to the collector. The alternating current of the signal fed into the base of Q1 modulates, or switches on and off, the current flow through the transistor. This has the effect of amplifying the original signal. C3 only allows the amplified signal through to the base of Q2, not DC current, which then does the same thing as Q1. The overall DC current flow through Q2 is regulated by the variable resistor or trim pot marked Q2 bias. The further amplified audio signal then passes straight to the base of Q3, and the same thing then happens. The current flow through Q3 is regulated by the variable resistor or trim pot marked Q3 bias. This setup of the collector of Q2 feeding straight into the base of Q3 is called the Darlington configuration, and is intended to overcome the relatively low gain nature of germanium transistors. The output volume can be controlled by the variable resistor or potentiometer shown as the volume control. As the pot is turned down, more and more signal is shunted to ground. The Tone Bender's attack control, as it is termed, is a straight copy of the terminology used on the Maestro fuzz tone design. On the Maestro unit, it should have been more properly called fuzz, as it controls the amount of fuzz. It achieves this by altering the bias of Q2. However, the way it works on the Tone Bender is different to the Maestro's design. It is a more sophisticated bias control, feeding signal back via resistor 5 into the base of Q2. Its job is to reduce the gain of the gain stages, making the whole circuit more stable, as well as being able to vary the degree of fuzz. If you are going to order the FuzzDog kit, at the same time you will also need to order a 4-way ribbon connector, a SIL socket if you're going to use their direct connect ribbon connector. The ribbon is pressed into the connector, and a pair of knobs. Available elsewhere are transistor sockets. I recommend getting 3 of them. You just trim the transistor leads to length and push them into the sockets, you don't solder them in. This particular kit uses germanium transistors, which are PNP transistors. Accordingly, it is positive ground, which means that ordinarily you wouldn't be able to power it using a standard power supply. However, FuzzDog provides an optional charge pump which reverses the polarity of the 9-volt power supply and allows you to use a standard power supply. This is mounted on the same daughter board as the true bypass switch circuit and the LED. So our video looks at assembling both circuit boards and then putting them in the enclosure to make a pedal. I should stress that I bought and paid for the kit and no one has paid me to do this review. Lastly, before we go any further, I should emphasise that once you've ordered your kit, whatever it is, check what's been delivered against the parts list as soon as it arrives. I'll go into the reason for this towards the end. I am grateful to Damn Pedals for the history of the Tone Bender outlined on their website www.stompboxes.co.uk. Damn's founder David Main has done a huge amount of research on Tone Benders and has made recreations of classic models for solar sound. The first Tone Bender was designed by Gary Hurst and was first marketed in 1965 as the Tone Bender, a Gary Hurst design. Manufacturing by Solar Sound was taken up soon after. It was a 3-transistor design based on the Gibson Maestro Fuzz Tone. It used a Mullard OC75 and 2 Texas Instruments 2G381 transistors. It was used by famous musicians of the time including Pete Townshend, Jeff Beck, Mick Ronson and the Beatles. In 1966 the circuit was modified and now had only 2 OC75 transistors. This version is termed the Tone Bender Mark 1.5 by collectors. It sounds similar to the early Fuzz Face, which isn't surprising as they shared a similar circuit. The circuit was modified again soon after to encompass 3 OC75 or OC81 transistors and is known by collectors as the Tone Bender Mark II. This is the version that we're concerned with here. The Tone Bender is a simple circuit and the first models were made using point-to-point soldering, which means essentially that components were soldered directly to each other. This evolved to using strip board to mount the components. I am not particularly concerned about authenticity in terms of construction, so I was happy to go with the modern PCB construction of the FuzzDog kit. Solar Sound produced pedals for other manufacturers including Vox and Marshall. Marshall's Super Fuzz branded unit was the longest lived Mark II variant, being made from 1966 through to the 1970s. According to Damn, the Mark II that everyone wants is the Vox Tone Bender Professional Mark II. The Mark III Tone Bender was launched in 1968. This featured an additional tone control. It's a 3-transistor circuit with a germanium diode, mainly branded Vox. The Mark IV was launched in 1969. It had the same circuit but an upgraded case. From 1971, this unit was marketed as the Tone Bender Fuzz. If you want to compare different Tone Bender models, take a look at Rock and Roll Vintage's YouTube video called Need to Figure Out Which GMI Tone Bender is Right. I checked it out and to my taste the Mark II was my favourite, so that's the one I wanted to build. With older designs like the Tone Bender, which use germanium transistors, there are particular factors to bear in mind. Germanium transistors are notoriously inconsistent. If you buy from a reputable vendor, you will get transistors matched to the job in hand. Why are they predominantly PNP and hence positive earth? Apparently the physical characteristics of germanium made PNP easier to manufacture than NPN at that time. Germanium transistors are ambient temperature sensitive. Why is this so important? The key performance parameters for a transistor are gain and leakage, and they are both affected by ambient temperature. I should perhaps explain these more fully. Forward current gain affects how loud the signal is. It's the ratio between the current flowing between the collector and the emitter, and the current flowing into the base, as it's a ratio, it has no units. If you look at a data sheet, look for the HFE number. Leakage, which is inherent in all transistors, determines how noisy the transistor is. It is measured across the collector base junction and is measured in microamps. Acceptable leakage is typically below 300 microamps. Germanium transistors were largely superseded by 1970 by silicon transistors, which are more consistent and less temperature sensitive. The germanium transistors available today are largely new old stock. Germanium transistors give a slightly more spongy sound than silicon transistors in the same circuit. Boutique Tone Bender MKIIs use OC75 or OC81 transistors. Our kit comes with a more plentiful and hence cheaper AC128. This transistor has a pedigree, having been used in the early 60s fuzz faces. According to Small Bear Electronics, the ideal current gains for a Tone Bender's transistors should be Q1 75 to 100, Q2 70 to 85, Q3 120 to 140. The OC75 had a gain range of 60 to 130, while the OC81D had a gain range of a minimum of 20. The FuzzDog unit uses AC128s, which have a minimum gain of 45. Because they were so inconsistent, it is usual for providers of transistors to have to test them to select examples with the correct gain and leakage characteristics. In this video, we assume you know how to solder. If you don't, it's a good idea to research it and practice on a piece of scrap Vero board. It is vital to be well organised and to have all the tools to hand before you start building. You don't want to be in the position of making a mistake and not having a solder pump to hand to uninstall a component. Here is a list of tools needed to assemble a circuit board. Multimeter. Having a multimeter to check resistor values will considerably speed up the process compared with trying to read the colour codes. Wire strippers. You will need to dress the leads to the sockets and switch. Helping hands. These are great for holding PCBs when doing soldering. Heatsink. Vital when you are soldering heat sensitive components like diodes and transistors. Desolder pump. This is just in case you make a mistake. Needle nose pliers. These are to bend leads accurately to fit the board. Solder wick. Again in case you make a mistake. Solder. Wire snippers for trimming component and wire leads to length. And a soldering iron. 25 watts with a narrow pointed bit is a good choice. To assemble the circuit boards in the case and complete the unit, you will also need an adjustable spanner for tightening nuts, a small slot head screwdriver for screwing on the knobs. It is also useful for adjusting trimmer pots, a crosshead screwdriver for the retaining screws for the base of the enclosure. Lastly, for us older chaps, a magnifying glass is a good idea for reading component reference numbers off the components themselves. This particular kit comes with one main board to house the Tone Bender circuit, but I also ordered the optional charge pump daughter board so that I could run the pedal off a standard power supply, so we will be assembling two circuit boards. The main board houses the Tone Bender circuit and potentiometers, while the daughter board houses the charge pump, foot switch and LED. Before we start, I just wanted to say that in woodworking an important principle is measure twice, cut once. The equivalent in electronics is check twice, solder once. One snag that I hit was that FuzzDog has updated the main board layout but not updated the instructions. Thankfully, the picture of the main board, which you can buy separately, had been updated, and I was able to put a sheet together using this picture from the website, which helped me understand what went where. You will find it most efficient to install components in height order, starting with the lowest. In this example of a Tone Bender pedal, we're starting with the resistors. Rather than loosely insert a number of components before starting to solder, it makes for a neater job to solder each component in turn. There aren't many components to this circuit, so it was relatively simple to solder the resistors in place. The capacitors were more challenging simply because you need to get the right values of capacitor in place the correct way round. I know that the positive lead is always the long lead and that the negative lead is indicated by a stripe on the side of the capacitor, but that doesn't stop me checking just one more time to make absolutely sure. I needed a magnifying glass to check the component values. After ensuring that all the resistors and capacitors were in place, the next step was to install the transistor sockets. The sockets don't come as part of the kit, but I feel happier using sockets rather than taking the risk of burning the transistors to a crisp with a soldering iron. Since the holes in the PCB are designed for transistor leads, I had to file down the feet of the sockets to fit the PCB, but that wasn't too onerous. I then soldered the sockets in place. The time came to install the trimmer pot. The bias for Q3 should be adjusted by setting the resistance of its trimmer pot to 8.2K before it's installed, and this was checked with a multimeter. I set the Q2 trimmer pot wiper to the centre before installing. With both trimmer pots soldered in place, I then soldered the volume and attack pots in place. A good lesson in putting anything together is reading the instructions all the way through before you start. Fuzzdog offers a neat wiring solution which they call their direct connection ribbon connector. They recommend that at the main board end you solder a 4-in-line silk connector to the board and push the ribbon into the connector. It was easy enough to do, but had I realised this earlier, I would have soldered it in place earlier. I could now put the main board to one side. Charge pump. The charge pump daughter board has diodes and an integrated circuit as well as capacitors and a current limiting resistor. I decided to install the diodes first. They're installed vertically, and again polarity is really important. Fuzzdog's convention is that the negative lead goes through a square pad. The negative lead on a diode is indicated by a stripe. Although I know this, it didn't stop me checking just one more time before I got stuck into soldering. Use your needle nose pliers to bend the leads at right angles. When soldering semiconductors like diodes and transistors, it makes sense to use a heatsink on the lead to ensure that you don't damage the device. We're using a crocodile clip here. Having installed the diodes, we can then move on to installing the capacitors. Finally, it is better to solder an integrated circuit socket to the board rather than solder the integrated circuit directly to the board, and Fuzzdog provides a socket. It was at this point that I discovered that the LED was missing. Unfortunately, I had ordered the kit a couple of months before and just put it to one side to assemble it later. It didn't feel right going back to the kit supplier and saying, "Hey, you know that pedal that you sold me 2 months ago? Well, the LED was missing." So I thought that the simplest thing to do was just order one off eBay. They're cheap and it's easy to do. This is where I encountered some problems. The circuit voltage is 9 volts of course, but LEDs are rated generally at 3 volts. You therefore have to use a current limiting resistor to prevent the LED from overheating. Fuzzdog usually supplies a 2.2k ohm resistor, which I also didn't have. So I selected an LED rated at 9 to 12 volts on eBay. They have a resistor already soldered onto the lead. On the board, all I had to do therefore was just solder a jumper where the CLR resistor would have gone. I should have stopped at this point, but I didn't. I thought it would be easy enough to solder in the LED and resistor when they arrived, but it wasn't. Then came the push button switch, which is really easy. You just have to make sure that you keep it flat to the main board, tack it in place at 2 corners, and then solder in the rest of the connections. I then soldered in the leads connecting the board to the power socket and the in and out sockets. It required a magnifying glass to identify which pads to connect which leads to. The fact that you were dealing with positive earth transistors induces a degree of fear, I have to say. But you've just got to be patient and work through it all logically. Unfortunately, soldering in the LED and jumper would have been a lot easier before I assembled the entire board. The LED was relatively easy, but after struggling to solder in the jumper, out of frustration I eventually soldered in the jumper from the bottom, as you can see. Not a very elegant solution, but it works. The upside of all this is that I got to pick a blue LED while the standard LED normally supplied is white. The last thing to do was insert germanium transistors, which are marked 1 through 3 into the sockets. As a condition of providing troubleshooting support, most kit providers will insist that you test the main board to ensure it works before assembling the pedal. That way you and they can confine fault finding to the main board. For a more tidy build, the 4-way ribbon connector and daughter board works well. Look at this pedal with wiring straight to the switch compared with a ribbon connector. But how do you test the board without soldering the ribbon cable and ensuring that you keep things tidy? You don't have to, but I recommend buying a board tester. Fuzzdog do one for only £10 and it will make life a lot easier if you're going to build a few pedals. You can see from this picture that the board tester has a built-in foot switch and connectors for power and audio. You just hook up the direct connect ribbon connector from the main board to the sill socket on the tester and you can easily test the board. Here's a compressor board connected to the board tester and on test. The tone bender passed first time. Now it's time to install it in the enclosure and wire everything up. Having assembled the two boards, we can now install the main board, daughter board and sockets in the enclosure. The hard part in putting together a pedal is assembling each board. Putting the boards, jack sockets and power socket in the enclosure is pretty straightforward. Here are some tips on making the process as smooth as possible. Mark each socket and potentiometer location on the enclosure with a Sharpie. As you're working upside down, it's quite easy to mix things up if you don't. It makes sense to colour code your leads, so I use black for ground connections, green for signal connections and red for power connections. You might just be able to see the red power lead from the power jack to the charge pump in this shot. Before installing the charge pump daughter board, the last thing you do is solder in place the ribbon connector. You then install the main board and push the ribbon connector into the sill connector in the main board. I then just quickly tested the unit before screwing on the base. Fuzzdog suggests that you adjust the bias of Q2 by ear. I had set the trimmer pot wiper to the centre before powering up, and so I just adjusted the pot until it sounded good to me. Fuzzdog gives suggestive voltages for the transistor collectors, but I was concerned about shorting out the circuit in a tight space. Perhaps I should have checked this during the mainboard test and before I assemble the pedal. Another learning point. So how does it sound? I have recorded some examples of the tone at different settings. I won't say what amp and cabinet I use until the end. For the first tests I used a Fender Strat. The settings are indicated on the screen. I experimented and wanted to see what my ideal settings would be. I eventually settled on the volume knob at 12:30 and the attack knob at 10 o'clock. I decided to use my Squier Telly with Seymour Duncan pickups. I used a moderately overdriven amp. The pedal and guitar settings are indicated on screen. I found the pedal particularly usable with the guitar volume knob backed off a little. This gives some very pleasant distortion without being too over the top. Oh, I almost forgot. I was going to mention the amp and speaker I used. Well, here they are. Yep, a Mooer GE200 multi-effects pedal. I used the P109 normal clean amp settings for the test with the Strat. On the Mooer, that's the Deluxe Reverb clean sound. For the overdriven amp sounds, I used the US Blues OD setting, which is Mooer's emulation of the Fender Blues Deluxe. I didn't know how well the GE200 would work with the Tone Bender, but I was pleasantly surprised and decided to use the audio clips produced with it. It was much easier than miking up an amp and a cabinet. I love building this kit. The first thing to stress is that we should all be grateful that there are firms like Fuzz putting these kits together, and they deserve to be supported. You can pay an awful lot of money for an original example or indeed a boutique ready-built unit. If you're on a tight budget like me, it's great to be able to build an eminently usable unit which cost me just under £67. This unit has features which the originals and boutique versions generally don't. It can be powered from a standard power supply unit and so is easy to include in your pedal board. It's true bypass, so when it's switched off it's out of your signal path. It has an LED indicator light to show you when it's on or off. This particular pedal kit has bias trim pots so you can alter the character of the unit to suit your tastes and needs. It's in a compact pedal board friendly enclosure. I particularly like that Fuzz offers the Hammond 1590B enclosure as their standard enclosure. It has a quality feel about it. When you're building a pedal, sometimes things will go amiss. If it's anything serious, Fuzz responds quickly and professionally. It was my own fault that I didn't check what had been sent when I was sent it. Sometimes not everything will go smoothly and you have to learn how to improvise, which I did. For example, the outdated assembly instructions threw a bit of a curved ball, but it forced me to understand the circuit board a lot better. I am delighted with the results. I put pedals like this together to support my musical projects, and I am happy to have a bare aluminium case with the legends written on in Sharpie. However, at some point I will paint the case for my Tone Bender and my other self-built pedals. That'll be the subject of another video. So there we have it, a classic pedal in a compact, usable package for relatively little money, and great fun building it. What's not to like? I'll be thinking hard about my next Fuzz project.